Good morning, everyone. Today's lesson is going to be 4.9, modeling with polynomial functions. So this is actually the last lesson of chapter 4 that we never got to cover before midterm, so we're just going to do it now. All right, you know that 2 points determine a line and 3 points not on a line determine a parabola. In example 1, you will see that 4 points not on a line or a parabola determine the graph of a cubic function. Remember, a cubic function means it's a degree 3 polynomial, which means the largest power is 3. Write the cubic function whose graph is shown. Well, if you look at the graph and the points that we see on the graph, we have 1, 2, 3 x-intercepts, and then we also have a y-intercept. Now, I know it's been a while, but hopefully you remember from what you studied from the midterm that when you have the intercepts, the x-intercepts of a function, and then just one other random point, you can use intercept form to graph the function, or to write the rule of the function. Now, with polynomials, it's no different. So if this was a quadratic, we would put it in intercept form. In this case, the cubic function, we're going to put it into factored form. So what that means is we have x-intercepts of -4, 0, which means we have a factor of x plus 4. Another one would be 1, 0, so that would be a factor of x minus 1. An x-intercept of 3, 0, so a factor of x minus 3. Okay, so now I'm going to take that information and I'm going to put it together. And I know that the cubic function would be y equals some potential a value times all the factors, which came from the x-intercepts. Now, this is because I don't know if there was a stretch, a shrink, or a reflection. All right? Now, again, if you remember, this here is a point on the graph, x comma y. So if we have a point on the graph, then that means this is x comma y. So I'm going to use that information and plug it into this rule so that it can solve for a. So y is -6. A is the value I don't know, but I'm trying to figure out. Then you have 0 plus 4, 0 minus 1, 0 minus 3. So that's going to be 4 times -1 times -3. That's positive 3. That's 12. So 12a, divide by 12 on both sides, you get -1/2. So there is both a reflection and a shrink that's taking place here. Okay? So now that I have the value of a, I can write the function that models this graph. So the function f of x is equal to -1/2 times x plus 4 times x minus 1 times x minus 3. And that would be our final answer. All right, moving on. When the x values in a data set are equally spaced, the differences of consecutive y values are called finite differences. All right, this is something we looked at in a previous lesson. This is when you subtract the y values until you get the same number. So remember, this is where we learned it, section 2.4. The first and second differences of y squared were as follows, that we see here. So because you had to take the difference of your y values 2 times, you had to do this 2 times, you knew it was going to be a quadratic function, a degree 2 polynomial. All right? So if a polynomial has degree n, then the nth differences of function values for equally spaced x values are non-zero and constant. So that's just a fancy way of saying that if the function has a degree of n, then you have the nth differences being the same number. Okay? And the opposite of that is true. If the nth differences are the same, then you know it's a degree n polynomial. Okay? Use finite differences to determine the degree of the polynomial function that fits the data, then use technology to find the polynomial function. All right, so I need to start by subtracting my y values. Now, remember, the way in which we do this might seem a little bit backwards, but you can look at this section up here to just remember. We're doing 4 minus 9, 1 minus 4. So we're working a little bit backwards. Okay, so if I do 4 minus 1, that's 3. If I do 10 minus 4, that's 6. That's 10, 15, 21, 28. Okay, the values are not all the same, so I know that it's not a linear function because that work that we just did was the first differences. So I have to do it again. Let's use a different color to switch it up. Okay, so now I'm going to do the same thing. 6 minus 3, 3. 10 minus 6, 4. 5, 6, 7. Okay, they're still not the same number, so it's not a quadratic because the second differences are not the same. Okay, so now let's keep going. 4 minus 3, 1. 5 minus 4, 1. 1, 1. Okay, because after doing this 3 times, we get the same number. What type of function of this? F of x has to be a cubic function, a degree 3 function. Okay, so f of x is a cubic function. Okay, and then it says use technology to find the polynomial function. So again, I can never show you this part. I might upload a video of it onto Google Classroom. But for right now, I'm just going to talk you through it. All right, so turn on your calculators. And what we want to do is we want to go to add lists and spreadsheets. Okay, so you can click the home button, you can click new, and then click add lists and spreadsheets. You can also do control doc, and that would give you lists and spreadsheets as well. Once you have that open, next to A, type in X, next to B, type in Y. Do not type anything in the row that begins with an equal sign. And then from there, just start plugging in your values. So in the X column, I'm going to do 1, 2, 3, 4, 5, 6, and 7. In the Y column, I'm going to do 1, 4, 10, 20, 35, 56, and 84. Make sure you hit enter after each entry. Okay, once you have that information put into your calculator, click Control Doc and go to number 5, Add Data and Statistics. What should appear on your screen is the points that you just typed in, but we have to label our X and Y axes. So on the bottom, on that horizontal section, label that X. On the left section or the vertical area, label it Y. And then we want to click Menu, Analyze, Regression, and we're going to do cubic because we know it's supposed to be a cubic function. So we're going to say Show Cubic. Okay? And then what should happen is you should get a function that appears on your calculator. Now, I'm getting y equals 0.1666666 whatever 7x cubed plus 0.5x squared plus 0.3 repeating x plus negative 7 e to the negative 12. Okay. That is very close to 0. That negative 7e to the 12. And that's just scientific notation, by the way. That just means negative 7 times 10 to the negative 12th power. Okay? Now, we're not going to write it like this because it's long and complicated. We should know that 0.167 is very close to 1/6, and 0.3 repeating is close to 1/3, and 0.5 is x squared. So, using technology, that was terrible. using technology, f of x is equal to 1/6 x cubed plus 1/2 x squared plus 1/3 x. And honestly, I don't know why it's giving us that -7e to the -12th, because if you look here, it's very close to 0. So that's what we're going to do. We're going to leave it at 0. Okay? So that's the function that models the data. Okay, last example. In examples 1 and 2, you found a cubic model that exactly fits a set of data. In many real-life situations, you cannot find models to fit data exactly. Despite this limitation, you can still use technology to approximate the data with a polynomial model. This example, excuse me. This example shows the number y of bald eagle nests counted in Ohio t years after 2000. Find a model for the data. Use the model to estimate the number of bald eagle nests in 2015. Now, I know it's 2 tables, but this all represents the same information. It's just that you have it separated because it doesn't fit on the page. Okay, so again, most of this I'm going to do without you guys seeing it. So I'm just going to talk you through it again. Go back to your calculator, click the house or the on button, and hit new. When it says, do you want to save unsaved document, say no. And again, what should pop up on your screen is a list of options: add calculator, add graphs, whatever. You're going to do lists and spreadsheets. Next to A, type X. Next to B, type Y. Plug in those values, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 14, 17. Again, make sure that you're typing that into the X column and you're leaving the row with the 0 blank. Then we have 63, 73, 79, 88, 108, 125, 150, 164, 184, 215, 213, 200, 221. Okay, type everything in, and then hit Control, Doc, add lists and spreadsheets. Sorry, not lists and spreadsheets. Add data and statistics. Label your X and your Y variables, and you should get something that almost looks like a weird shaped M. Okay. What kind of function is this? I don't really know yet. Well, it's definitely not quadratic. It's definitely not linear. So it could be cubic or quartic. So let's try both. So if we do a cubic, I'm going to round my values so that what you should get, if it's cubic, is f of x equals -0.052, and it would be x cubed, but let's do t cubed since that's the variable that they use, plus 0.2t squared plus 3.6t plus 55. Okay, so that would be if it was cubic. Let's see what it would be if we did a quartic. So menu, analyze, regression, quartic. For a quartic, we would get f of x equals 0. Should be f of t actually, but anyway, equals 0.0202 t to the fourth minus 0.734 t cubed plus 7.79 t squared minus 11.0 t plus 70. Notice the digits after the decimal keep decreasing as we go. That's another way that you could round functions when you write them. Okay, so that's cubic and quartic. Okay, So which of these two are going to be the right one? I'm just going to tell you because the way to figure it out would require more graphing, and I feel like I'm just talking at you guys at this point because you can't see my graphs. So the one that closely fits the one that fits the model better is going to be the cubic model. Not the cubic, the quartic. So this is the one that we're going to go with, okay? When we have class next time, I'll explain to you why it's the quartic when we can do the graph. Okay, so we're not going to use the cubic, we're going to use the quartic to answer this last question, which is estimate the number of bald eagles nests in 2015. So that would mean that T is 15, which means we need to find F of 15. And when you do that, you get about 206. So the number of bald eagle nests in 2015 was about 206. Okay, and that's it.